Hi, I'm Carter. This is me explaining the physics in movie clips, 3 movie clips. So the first one had to be Up because I feel like that's a really obvious one, and I've heard people talk about that before, actually, and it's just kind of a ridiculous one. But essentially, it's the part where the balloons are released and it lifts the house into the air. Um, I looked it up and it says that the estimated number of balloons in the animation is 21,000. 21,000 helium balloons. Um, so, did some other quick looking things up. If we're assuming that a little house like that weighs 150,000 pounds, um, about 68,000 kilograms is what that would be. Um, just a little bit off, but rounded off to 68,000. That's how much the house would weigh. And then the buoyant force of a balloon, that's about 11 inches around. Um, you have to figure out how much air that displaces to figure out the buoyant force. So you multiply the density of air displaced by that volume, which is about 0.0114 um, cubic meters, and that displaces about 0.014 kilograms of air, is what one balloon. That's the amount. So if you do 68,000, oh, and besides that, the balloon itself, the string and the rubber weigh 0.08 kilograms. So the 0.014 minus the 0.008, it leaves you with a lifting force of 0.006. Um, so if you divide 68,000 kilograms by 0.006, you would need just over 11 million balloons to lift this house. So um, Disney had an estimate for it too, that they did a while ago, saying they would need 23.5 million balloons, which is close to double my estimate. But maybe their balloons are lighter or they're um, smaller than mine, or I guess that would mean they're heavier or they're smaller than the balloons I was doing calculations with. But anyway, just in the tens of millions. So that clip is not realistic. The next one, Iron Man. Um, Tony Stark creates a new element, I guess, by pointing his laser thing, or like a fictional particle accelerator at a triangular piece of metal, and wrecks his house in the process. Um, so he turns that thing and he points it at the metal and it glows really bright. And then Jarvis is like, "So you created a new element." But we know every naturally occurring element is on the periodic table between 1 and 118. So, and an element is defined by the number of protons that it has, regardless of the number of neutrons, because changing neutrons would make it into an isotope, or changing electrons would give it a charge. Um, so, yeah, essentially pointing his laser thing at that, and it just looks like a laser, which might change like the charge of an atom, but wouldn't change the element. But I did some research, and this is something that's been tried by other scientists, where they try and create like atoms that have more than 118 protons, but they don't last very long, and it's just not really a thing. So Iron Man doing that, it's not going to work out. And so, um, yeah, not too much math there, just the fact that he can't have an element that has more than 118 protons, at least not by pointing a fancy laser at a piece of metal. So, the last one that I was thinking about was Superman, and there's a few things I have to assume for this one. So the part of that one that I was looking at was when the lady's like holding onto the helicopter, but then she falls, and then Superman goes to like catch her before she falls. So, I'm gonna assume that this lady weighs like 130-ish pounds, which is like 59 kilograms. So that's what I used for my calculation. And I counted. This lady was falling for 8 seconds before Superman caught her, which is a long time. So with the rate of gravity, if we just assume that the acceleration is 10 meters per second squared, then that means she would be falling at about 80 meters per second squared. I know I looked it up because I wasn't sure, but it says terminal velocity for a human falling is usually around like 60-ish. But for my calculation, I'm going to assume I'm going to kind of skip past that and say it was probably like 80 meters per second she was falling, because terminal velocity does go up depending on the position your body is at, and 60 is like if you're like completely spread eagle. So 80 meters per second, and she weighs 59 kilograms. So 80 times 59 is 4,720. So that's a lot of force, a lot. So when you're watching the clip, what I kind of assumed, what I was looking for is like the impulse. Like Superman comes up and like catches her and like slows down her fall so that she like doesn't get hurt. But it doesn't look like Superman does that at all. In fact, it doesn't look like he even stops moving upward when he catches her. Like at the very, very least, he would have maybe stopped. So he might even be adding to the impulse, but I'm going to calculate this like he stopped. And he's the Man of Steel. So obviously when he hits her arms, it doesn't look like his arms move at all. So it's basically like her like hitting two like steel rods or like concrete or something. So the impulse, the time interval is very, very short. I just am gonna assume that it's 0.01 seconds. So 4,720 divided by 0.01, 472,000 newtons. So she should be dead. And my video is too long, but that's why that one is not realistic. But anyway, none of these are realistic, but movies are fun to watch.